understand the basic properties of logarithms. Now, I want to start by saying properties of logarithms aren't super difficult once you get them in your head. I really struggled at the beginning of my logarithm career way back when, and it took me a few months before all of a sudden it just clicked. And once it clicked, then everything made sense. So if it starts being really difficult for you, it's okay. Just keep going with it, okay? Keep practicing. So first, let's talk about the basic properties. Now, these basic properties come into play in terms of, we already know these, right? B to the 0. Well, anything to the 0 power of 1. I need you to keep that in mind, okay? And B to the first is B. Well, of course, B being any real number. All right, we know those already. That's great. Moving on. The inverse properties, these are ones that sometimes take a little longer to kind of get in your head. So if I have the log of B to the x base B, this is the same as just x. And that is because if we look at log of B to the B, just that piece, well, think about it has to equal something. Well, B to what power equals B? Well, that means this unknown thing has to be 1. So, oh, excuse me, that's not what I wanted to do. So this piece right here is equal to 1, and that's why this all works, okay? By a different power of logarithms, the x comes out front, but we won't get into all of that. All right, so just if you remember that, it keeps your life easier, that by the inverse property, the log of B to the x base B is indeed x. And similarly, if we have B raised to the log of x base B, that also equals x. Now, for both of these, x must be greater than 0. Okay, so x has to be a positive number. But it makes sense because logarithms and exponentials are inverses, right? The base of the logarithm, base of the exponent. If they match, then you have just the exponent. We're going to do examples of all of these. Now, the one-to-one property says, if the log of m base b equals the log of n base b, then m equals n. And that should make sense because if we have the same base, so the log of the same base, then these things must be the same. Must be the same. Okay, that's one-to-one property. Okay, let's evaluate the following. The natural log of e to the 8th. Well, remember what a natural log is. A natural log is simply a log with a base e. Right? That's what this means. So if I have base e for my logarithm and base e for my for the base of the exponent, then this is simply equal to the exponent. So that just equals 8 by the inverse property. And letter B, if I have 4 raised to the log of 7 base 4, what is that? Well, same idea. Base of the exponent, base of the logarithm are the same. So by the inverse property, I just have 7. What is the log of 1 base 2? Well, let's make this equal to x so that we can say, well, let's write this as an exponential. 2 to what power gives me 1? Think back. Anything to what power is 1? Well, anything to the 0 power. So x must be 0. So log of 1 base 2 equals 0. If, letter D, if the log of x base 4 equals log of 12 base 4, what is x? Recognize that we have the log base 4 of both sides. That means the arguments of the left and right side must be true. So x equals 12 by the one-to-one property of exponents. And that right there are basic properties of logarithms. I think I said exponents before. Please excuse me. Exponentials and logarithms share a lot of the same or similar properties because they are inverses of each other. But here we are playing with logarithms. Thanks all.